Next topic we're going to look at is joint lives, and like every other actuarial topic, you can go to town on this and go into enormous amounts of different permutations and combinations. Let's look at the orange tables. Let's look at the sort of notation. So I would go through the orange tables, or it's the red tables now, and basically pretty much memorize everything. Well, not memorize, but make sure you can make sense or understand of everything that's in there. So I'll just put them to basically the right scale. So I'm not going to go through all of these now. I'm just going to show you where the part is on sort of joint lives, and it's all this sort of part here. Okay, so really, if you've got two lives, X and Y, so male aged X, wife aged Y, or you could change it round or whatever, you tend to have the two letters X and Y after the A. So in this case we've got X, Y and Z, just to sort of generalize it. And the only real thing you have to worry about with the notation is if you have the line over it, okay, that means it's dealing with the last survivor. Okay, if you don't have the line over it, then it's dealing with the first death effectively. So that's the only thing you really need to sort of remember, which way round it goes. Then a two there, and you never see in practice someone with three lives. So in that case, as it says there, an annuity payable so long as at least two of the three lives are alive. Then again, a probability on the same sort of basis, but basically what we're dealing with is this situation where we've got an X and a Y, two letters after, and it's the life aged X and the life aged Y. If there's a line over it, you're dealing with the last death. If there's not a line over it, you're dealing with the first death, essentially, and every other part of the notation works the same. Okay, so let's have a look at how the maths is going to work, and the assumption we always make with the maths, okay, is that these two lives are independent, or we're essentially making that assumption wherever it's necessary. Otherwise it doesn't, things just don't really sort of work mathematically. If the lives are not independent, as in reality they're not going to be independent, then you would have to just have you'd have to have sort of fully two-dimensional tables, but that means there's no real math to do because you're just reading off the fully two-dimensional table. So let's look at the basic maths we need, and really what I'm going to take you through is the logic, the way you need to think about stuff, and then I will leave it to you to work out how to actually do stuff. So the first thing we need to look at is probabilities. So remember we had TPX, the probability a life aged X survives for T years. We also had TQX, the probability a life aged X dies within T years. Okay. So now we have the slightly more advanced notation, TPXY. Okay, so remember, if it's just XY, we're dealing with the first death, okay? Whereas, as opposed to TPXY with a bar, we're dealing with the second death. Okay, that is the second death that concerns us. This is the first death. So what is this probability? This is the probability that the first death has not happened. Okay, P is survival, Q is death. So if you're dealing with the first death, you're dealing with the probability that no death has taken place. Well, the probability that neither death has taken place is, assuming they're independent, which we are assuming here, is the probability that the death of X has not taken place times by the probability the death of Y has not taken place. And that's it. Okay, so that is formula number one. Do you remember that formula? If you're having to remember that formula, you're not understanding what's going on. So I would say no, don't remember that formula, understand what's going on. Okay, and now to see if we can understand what's going on, again, let's look at TPXY bar. Okay, so this now we're dealing with the second death. So it's a survival probability. So this is the probability that the second death has not taken place. Okay. So the probability the second death has not taken place is the probability that at least one is still alive. Okay, so it's 1 minus the probability that both have died. Okay, so it's 1 minus TQX times TQY. But we'd normally express it with P's, so it's 1 minus T TPX times 1 minus TPY. Okay, and that's all we have to do with probabilities. It's as simple as that. But normally, if we're doing these calculations, we're looking at annuities or assurances. Now again here, we're going to go back to look at the tables, and what we're going to notice, okay, is what we're given is that now in practice now you would just have a function and it'll probably deal with each different thing, reversion annuities or joint life annuities, first life annuities and whatever. But you'll notice in the tables you're only given A.XY, so you're only given the annuity which pays while both lives are still alive. Okay, and the reason for this is you can work out what the others are. Okay, so what have we got? We're given a table of A.X, we're given a table of A.Y, or annuity due X and annuity due Y, and we're given a table of annuity due on the joint life of X and Y while they're both still alive. Okay, let me sort of say something that might seem like common sense and might not. Okay, let me give you another type of combined life annuity. This means a reversionary annuity. So this annuity is payable if Y is still alive when X has died. So a typical spouse's pension, that sort of thing. Let me posit to you the following relationship. AY minus A.XY. Okay? If you say, well, that's obvious, then I'd say there's a 10% chance you're very, very clever and a 90% chance you are jumping the gun. It is true, but we need to be careful. These are expected values. Okay, they're not just probabilities or something. They're not just, they're not simple terms. They are expected values. So there's a sum of a load of cash flows multiplied by the probability those cash flows take place. So the assumption that this works is non-trivial. But the way we do it, or the way to think about it, is to just think about the following diagram. Okay, so we've got two lives, X and Y, and those lives can be alive or dead. Alive or dead. Okay. So now we can think about A.X reversionary Y in terms of in what circumstances will this pay out. Okay, so let's do this in green. So A.X reversionary Y pays out if X is dead, okay, and if Y is alive. So I'll put a little green tick in there. Okay, now let me do in blue A.Y. Well, A.Y pays out if Y is alive and X is dead, and it pays out if Y is alive and X is alive. Okay, now let's look at A.XY. This, remember, pays out when both lives are still in play. Okay, so this pays out when A is alive, when X is alive, sorry, and when Y is alive. Okay, so at every point in time, this diagram tells us what is being paid. So the reason why this relationship is true is because the underlying cash flows are identical for the left-hand side and the right-hand side of this equation. This is an equation of expected values. The reason why this equation of expected values is true is because at every point in time, this structure is paying out if and only if this structure is paying out. Because X reversionary Y is paying out just if X is dead and Y is alive. A double dot Y is paying out in the here, and A double dot XY is paying out just here. So what this side of the equation does is give you £1 every year Y is alive, and which is that, and then take it off you if X is alive. Well, that is the same as giving you £1 if Y is alive and X is dead. So that's why that relationship holds. And if you think about this diagram, you can easily work it out. Okay? So hopefully by extension we can work out A double dot Y X. Hopefully that is fairly easy. But also the other thing we might need to work out is A double dot XY bar. Okay? A double dot XY bar pays out if either X or Y are alive. So it's going to pay out if Y is alive, which is there and there, or if X is alive, which is there. It's only not going to pay out there. Okay? Well, that's going to be a bit tricky at the moment, because how are we going to sort of match this? But we notice we haven't finished yet, okay, because we can also put in this diagram A double dot X, which pays out here and here. Okay, so how are we going to get A double dot XY bar when the only things we're actually given in the tables are that, that, and that? You may want to stop the tape and think about that. It's not too hard. A double dot X plus A double dot Y, okay, is going to give me 1, 2, 1, and I just sort of take off something which is only payable there, okay, which is the light blue one there, which is A double dot XY. So I don't need a table of A double dot, I don't need that. The ones I don't need are that, that, and that, because I can work them out.